Okay, so in the next couple of videos, we will talk about probability. And first thing we want to do is to introduce some basic terminology. And even before that, let's talk about some approaches to probability, of which there are three. So the first approach is the classical approach. And here we have a priori information given, so a priori means in advance. So for example, we know that when we roll a die, that the probability of rolling a 6 is 1 over 6. So that's known in advance. Then the second approach is the empirical approach, and here no a priori information is given. And in order to determine probabilities, we need to do some empirical work. So for example, we don't know whether students of a particular university regularly go to the gym. There's nothing that we would know in advance about the probabilities. So therefore we would have to conduct a survey of 100 randomly selected students, and then if that reveals that 60% of the students go to the gym regularly, we can assume that there is a 60% chance that a randomly selected student goes to the gym regularly. The third approach is the subjective approach, and here also no a priori objective information is given, and empirical work is not possible. So very often the subjective approach applies to a singular event. So for example, the outcome of a boxing fight between two first-time opponents may have to be evaluated by resorting to some kind of subjective information. And in this subjective approach, we will enter something which is known as Bayesian economics, and there are lots of interesting things one can do with it. Okay, so now some basic terminology. So the first terms that you need to know is the difference between mutually and non-mutually exclusive events. So mutually exclusive events would be, for example, rolling a 1 and a 6 in a single die roll. That cannot happen, and therefore those would be mutually exclusive events. And if we want to illustrate that in a Venn diagram, then we have the two events, like first roll a 6, 1 and a 6. So let's say, so then we would say, well, they don't overlap. It cannot happen at the same time. And so here maybe the yellow or orange bubble, that would be like the 1, and the blue would be the 6, and you see they cannot happen at the same time. They are mutually exclusive. Then when we have mutually non-exclusive events or non-mutually exclusive events, that would be, for example, rolling an odd number and a number less than 5. So they are not mutually exclusive. So if we say, for example, that the yellow bubble are odd numbers, so odd numbers would be 1, 3, and 5 on a die, and numbers less than 5 would be 1, 2, 3, 4. So the 1 and the 3 would show up in that area of intersection. Okay, so that's the difference between mutually and non-mutually exclusive events. And the next one is the difference between independent and dependent events. And the difference between independent and dependent events is often illustrated in the context of drawing from a bowl. So independent events are essentially scenarios in which you draw from a bowl with replacement. So when we go back to the example of rolling a die, if you roll a die and you get a 6 in the first roll, that doesn't alter the probability of rolling another 6 in the second roll. So the events are independent. So you could also think of a bowl where you grab, you can think of a bowl that has like 6 numbers or 6 balls in it, and if you draw one and one of the balls says 6 on it, then you basically put it back, and then when you have a second drawing, the chance of getting again a ball with a 6 on it is again 1/6. And so dependent events are then essentially drawing without replacement. So, okay, so the next term are complements or is complements. And the complement to event A is simply not A. And this is sometimes also called A prime and means not A. So in the earlier example, when we found, for example, that 60% of all the students of a particular university use the gym, then the complement to going to the gym would be not going to the gym, and that would be 40%. So the sum of the probability of event A and A prime, so that the event does not occur, they always must sum up to 1. And here's another example. Assume there is a bowl that has 10 chocolate squares, and 6 of them are made with dark chocolates and 4 of them are made with milk chocolate. Then in this case the complementary event to drawing a dark chocolate dark chocolate square is drawing a milk chocolate square. Okay, so important terminology is, okay, so we need to know the approaches to probability, the a priori and the empirical and the subjective. Then about terminology, we need to know that we need to distinguish between mutually exclusive and non-mutually exclusive events, and we need to distinguish between dependent and independent events, and we need to know the concept of a complement. Okay, so that was just the introduction, and we will build on those concepts beginning with the next video, in which we will discuss basic probability rules, and there the difference between mutually exclusive, non-mutually exclusive, dependent and independent events will play again an important role. But let's just stop here and then continue with basic probability rules in the next video.